All right, folks, if you can hear me, we're just about to get started. If you could type hi into the Google Doc, that would be great. I'm just getting all my documents open here, and we'll get started in about 2 minutes. I'm going to switch to the presentation. So you should be seeing now the marking period 2 exam review and tips. And if you can hear me all right, just give me a hi in the Google Doc. So we'll get started shortly, and then we will go ahead. Again, I mean, there's no problem if you have questions already. You can start numbering those under the question section, and I'll put a number 1 there. But remember, if you can just put your questions in any color, that would be great. I see we got a bunch of people joining us. All right, hi Robbie and Juliana. Hello from Trevor. All right, changing it up there with a little hello. That's always good. And we got about another 2 minutes. It'll be 8 o'clock. We're gonna get started on time. I want to be prompt with the presentation. It'll just be about 10 minutes. And then we're gonna head right to your questions for about 35 minutes. I'll take, and again, I said in the email, I'll take a little bit over time. If you have a bunch of questions that are good, we can deal with those in the extra time. Just getting all my apps open here. I got my Sketchpad. I got, hi Victoria. Hello Noah. And Gwyneth is here. She got the only board point ever in the history of review webinars. Went to Gwyn Gaynor. We'll see if anyone comes up with one tonight. But that was last time. Hi Brenda. And Daniel is here. Hello Daniel. All righty. So we got about 1 more minute. We're going to get started. Again, you should see the review presentation, which I'm going to give you all kinds of review tips, things especially you should study, format of the test, and all that good stuff. So you are not going to regret attending this webinar. If you are here, you are putting yourself in a position to succeed. If you're not attending live and you're watching it on the rerun, then you are putting yourself in a good position to succeed on this marking period exam. All right, so just about another, it's 8 o'clock on my watch right now. I'm going to give 1 more minute for everybody to get in here, and then we will go. Is it too quiet? Trevor says, where's the volume? Hang on 1 moment. People are typing in questions. All right, thank you, Trevor. Can you hear the volume now? Can you hear the volume now? How's that volume? Okay, never mind, it's better now. Thank you, Trevor. You know what? I didn't have my microphone plugged in, so that was not going to be heard very well. But now I have my microphone in, so you should be able to hear it pretty loud and clear. If you need it to be a little bit louder, then that would be great. Okay. We have some people typing in questions. If you can number those questions, that'll be great. And we're going to go ahead and get started with this presentation. So marking period 2 exam, review and tips. And here we go. Here is the test format. We've talked about it in class, but I'll give you a little bit more specifics here. There's going to be multiple choice. It's 14 questions. I suggest you spend about 20 minutes. And if you know your stuff, you won't have to guess. Stay tuned for a bonus tip on the multiple choice at the end, but all regular multiple choice stuff applies. If you are forced to guess, you want to use process of elimination, eliminate answers if you can. But really, if you know your methods, if you know all the terms, you know what you're doing, you're not going to have to guess. This is not a gotcha exam. There's not a lot of surprises. Most of the questions are based off of questions you've seen before on quizzes or tests. With the open-ended, there's about 5 questions, or there are 5 questions. And again, I say about 20 minutes. You will be allowed a calculator for that. And a big tip there is to know the chapter 5 practice, which is on the back of the study guide. And I'll take some questions there. Also be able to solve different types of equations. There's not really word problems with big applications, but you will be expected to solve some of those types of equations. I list there polynomial, radical, rational, and you want to have those tools in your tool belt. Be able to solve those. You are not allowed a calculator on the multiple choice. Can have it on the open-ended, but you're going to see you're not really going to need it too much. Again, so continuing with calculator stuff, we have just the statement. It's not really going to help much. There's not a lot of graphing. We've done that on quizzes and tests. There will be some graphs on the multiple choice section, and you have to pick out important features. But as far as the open-ended, I'm not really going to be asking you to graph. So calculator not strictly needed. If you know your terms and methods, you're not going to need it anyway. Perhaps it'll help you with some simple calculations. You got to do some calculation in a problem. You just want to verify it and go a little bit quicker. I think you should practice your mental math, frankly. If you're good at mental math, everything will be easier. But you can use a calculator to help you there. So calculator stuff, not a ton on this quiz or exam. What to know in general about functions. So really the first half of this year has been, I guess we could say, function analysis. We've analyzed all different types of functions. And here are some things you should know about functions in general. Whatever type of function pops up, you should know its end behavior, specifically the end behavior of polynomials based on their degree being odd or even, and also their leading coefficient being positive or negative. You should know how to find the number of zeros, or the number of zeros of a function and how to find them. That's related to the fundamental theorem of algebra. That's where a calculator could be handy. Find those x-intercepts. You should be able to use limits to analyze asymptotes, whether you're doing a limit at infinity to find a horizontal asymptote, or you're doing the limit as it approaches the vertical asymptote from the left or right to know where a graph is going. You should be able to analyze some limits, and again, you should be able to find x and y intercepts. So any function we've seen so far, you should be able to do those four things if presented with said function. Okay, sorry, I just noticed, Gwyn, you're saying you're having an issue with the closing of the webinar. Hello, Jimmy, Jess, Ryan, and Kang. Thank you for joining us. Gwyn, if that issue's been resolved, just indicate so. I don't know why it keeps closing on you. Sorry about that. Again, the full version will be uploaded to YouTube, so you can check that out at the end. But that's a little annoying if you can't watch it live. So let me know if it's fixed. Just take down that comment, but I hope you can get it to work. All right, but how about good old Chapter 5? So I said the Chapter 5 practice is important. There is going to be some questions from Chapter 5, and I already see a question on this, but Descartes' rule of signs, you need to know. There's one multiple choice question on it. I don't mind giving that away. It's really based off of whether you know Descartes' rule of signs or not. Conjugate root theorems. Need to know those as well. Remember, there's two. There's a complex conjugate root theorem and the irrational conjugate root theorem, which basically gives away another root if you're given one of the roots. So if you're given a root that's complex, you know its conjugate is also a root. Same thing with irrationals. If you're getting a certain irrational root, you know its conjugate is also a root. And that applies to polynomial equations, and that'll help you out with one of the open-ended questions in particular. You need to know polynomial long division. We did it a while ago, but you do need to know it. There is a question on the open-ended that will involve this. Not two variable long division. So we did do that in classes, a little bit of a challenge, but you don't need that here. It'll just be one variable. But you need to know that process and how to depress an equation when given some of the roots and solve for the rest. So sometimes you can depress an equation with synthetic division, and that's perfectly fine. But you also need to know the long division method. All right, Gwen, looks like you got that fixed. And hello, Kang is here, and Ryan. I don't know what this is next to Kang's name. Somebody could explain that. I don't know what that is. But we're going to continue here and go from there. We have question and answer time next. I just want to say again with the solving for the different roots here, remember we were given one root like -2 or something, and then you have to use synthetic or long division to divide and depress that polynomial down to a lower degree, and then you can get a new equation there and solve for that equation. So I know that was a pretty brief presentation, but look back over that PowerPoint. I did give some tips, and now it's going to spend most of your time for questions. So thanks for watching, and we're going to head over to the questions and see what type of questions you have. I reserve the right to go out of order if necessary here. So we have a sketch pad where I'm going to be pulling up some questions if we need to talk about them. And I'm going to have my Google Drive as well. Let me go to the screen sharing mode. I have to fix that so you can now see what I'm doing. So I'm going to stop screen sharing. You'll see me again. Hello, this is Mr. DeRosa here. I'm in my lair, also known as my office, you could say. And I'm going to give you my entire screen so you can see everything I'm doing. All right, let's take a look. Number 1. Okay, can you please go over how to write the equation of a polynomial when given some or all of the roots? Good question. I'll give some general remarks about that, and then we can see if you have any other specifics from there. But basically, no matter, you're going to want to start by looking at the degree of the polynomial. And sorry, I'm just getting my sketch pad ready here. I'm just going to paste a little blank space in so I can write on a blank canvas. Sorry, this is not the best way to go about this, but I'll get the job done. All right, here's my blank canvas. So, okay, solving polynomial equations given some of the roots. First, check the degree. The degree of the function is equal to the number of roots. That is according to the fundamental theorem of algebra. And remember, some of the roots could be double roots or triple roots, but we know that the theorem says this. So if you, for example, have a polynomial that's a cubic, in theory, that cubic can be written as an equation like this, where R1, R2, and R3 are the roots. So that's how you can write any equation of the third degree. When you know the 3 roots, it'll look like this, and just set it equal to 0 by the zero product property. The thing is, if it's a more specific, if they just say write a cubic equation, that would be good enough. If there are more specifics, this equation could possibly be adjusted by a constant multiplier in the front. So there's a chance that there could be some number here, like I'm just putting an A, that could be a 3 or a 4, etc., that you'll need to multiply by. But in general, that's how you write the equation for anything. So you'll be given some of the roots. Let's say you're given 2 as a root, you put a 2 in there. Let's say you're given 1 plus I as a root. You'll put a 1 plus I in there, and then by the complex conjugate theorem, you'll know that 1 minus I is a root. And you could put that right in there in R3. So then you would just simply do the multiplication and get a simplified equation in standard form. So that's how you would handle that. And I'm going to declare that one answered. If you want to know more specifics or you have something else in mind, feel free to ask that. But I'll say C webinar or C video presentation. Okay, we have some more questions coming in. I love the questions. Keep them coming. If you can't stick around for any reason, remember I did say there's going to be a special bonus at the end, but if you can't stick around for any reason, please just watch the video later. Let's go to number 2. We have here another question. Can you please go over how to determine if the leading coefficient is positive or negative, even or odd, back of review sheet? Also, do you use long division to depress an equation? Okay, good question. I did answer part of that already. Let's see, I'm running black here. But let me take the second part first. You can use long division to depress an equation, but you can also use synthetic division a lot of the time. So I'll say synthetic or long division is allowed. There are some restrictions on synthetic division, but if it's just a simple root, for example, it's like x equals 4 is a root, I would use synthetic. That's going to be the easiest there to solve for that. You can't use synthetic if you're dividing by something like x squared minus 3 or x squared plus 4, but if it's just a simple x equals 4 root, then you make it x minus 4, and you can divide by that with synthetic. Can you determine, okay, yes, end behavior is basically the second part of this question, and I'll talk about that on my sketch pad. Let's see if I can delete all this. Copy. I don't want layers. Oh, sorry for the delay here. So just delete everything. Example, I want a blank slate. Okay, so here we are, and talking about end behavior. So basically, to determine if a coefficient is odd, or sorry, coefficient is positive or negative. Oh. Hence the question on the review sheet. I hope you got my corrected wording. For leading coefficient, you don't care if it's odd or even. That was a typo. Leading coefficient, you only check if it's positive or negative. There was a typo that said even or odd, so that might have led to this question. With the degree, that's what you're checking, even or odd. Even or odd on the degree. So that's what I'm going to talk about briefly, and then I'll go over another question or two. So that's what you're checking here. I hope that answers your question. The rest is in the video presentation. And what do I mean by the rest? Here's the rest. So y equals x, y equals negative x, y equals x squared, or y equals negative x squared. Basically, you memorize these parent functions and you can determine the end behavior of any polynomial. So y equals x goes like this. This has a positive leading coefficient, and it has an odd degree, right? The exponent is 1. So we can determine that any function with a leading coefficient that's positive and a degree that's odd will go in this form of end behavior. It might look like this. I mean, that's not technically a function. Fails the vertical line test there, but it might do some weird things in between, but it's going to have that end behavior if it has a positive coefficient and a degree that's odd. Y equals negative x goes like this. Or just an example would be like 3x cubed is the leading term of the polynomial function. Okay, and then y equals negative x, same idea, except it can do whatever it wants in between. It should be a function. This fails the vertical line test. It should do whatever it wants in between, but at the ends, it's going to look like y equals negative x, and that will be a negative leading coefficient and a degree that is odd. Okay, hence the 1 there. So you basically just check what's the coefficient of these parent functions. Is it even or odd? What's the degree of these parent functions? I'm sorry, coefficient positive or negative. What's the degree? Is it even or odd? And then you just kind of match it up to whatever your graph says. Y equals x squared, we know goes like this. Again, the end behavior can do anything weird, but it's got to go like that. And y equals negative x squared goes like this. These have even degree. They're both even. And they have either a positive or a negative leading coefficient. And so you just match up your function or your graph, and you can see how it relates to one of these parent functions and make a determination about what you're looking at. All right, so I hope that helps with number 2. Again, if you need clarification, you can go below the bullets I did to answer your question and go from there. We'll next go to some people I can see are, not following the best decorum here. Try not to jump the line. If someone has a question already typed, you should type yours after theirs. Okay, I'm not going to name names. I know who you want to put the blame on, since you always blame this one person, but it's not usually her fault. Anyway, let's go to number 3. What do you mean by picking out important features as a graph? On the graphs is one of the multiple choice. I mean, by examining a graph, you want to look at, for example, the asymptotes, the intercepts, etc., and try to match it to an equation. Basically, the matching questions of your last 2 or 3 tests are what I'm talking about there. Can you match something up based on the graph by looking at select features, usually asymptotes, intercepts, or let's say end behavior? Okay. Can I go over Descartes' rule of signs? Yes. I think I've done that, though, in a previous webinar. So I'm going to say, see the Chapter 5 webinar first, and then I can go over that in class if you still have questions on it. But see Chapter 5 webinar. It's on my website. If you get to the YouTube page, whoever this person is, if you want to know more specifics on that, I can send that to you. But I've gone over it before on a webinar, and it takes a few minutes. But basically, you have to look at your notes. You got to count the sign changes of f of x, the function as it is, and f of negative x, the function with the negative plugged in, and then you can go from there. So that's what I'm going to say to start that. Count the sign changes, and you get a number for that, and then you make a chart based on Descartes' rule of signs. So I'll go over that in class tomorrow if you really need it. I prefer it for extra help, though, or first see that Chapter 5 webinar. That should help. Yeah, Trevor, thanks for signing your question. I think we should enforce that as mandatory next time. I didn't think to set that up, but it's nice to know who asked the question. I hear somebody seconded this question. That's extra helpful. Do we have to write equations based on given points like the back of the review? Yeah, how do we do that? Yes, that's why it's on the back of the review. See the answer to the first question. I just talked about how to write an equation. That's basically what you're going to do. Look, see which points are x-intercepts. Okay, whatever one's the x-intercepts are synonymous with roots. Okay, and if they're the roots, then you can use this form to set up an equation. Y equals x minus r1, x minus r2, however many of the roots there are. You can set that up using this form, etc. to find those, find that equation. Basically, you set it up like this. I'll just say r. I don't know. Let's say it goes up to r10. So there's 10 roots. That would be ridiculous. But however many roots there are, you write an equation in this form and see if there's any other constraints. So basically, and then you just use multiplication, simplify the equation, standard form. So that's really what you're doing there. The one additional constraint, what do I mean by that? Well, there could be something like if they also give you a point on the back of that worksheet, they give you y-intercept or other point, you need to take that into account, and you're going to have to solve your equation, whatever it is. You just have to consider that there could possibly be a multiplier or some adjustment factor, like our transformations, a number a in front, and you're going to have to solve, plug in the points, and solve for a. Okay, that's if necessary. I can show the steps for that tomorrow, but basically that's some help with how to do that. You set up the equation in this form, x minus r1, r2, r3, etc. And then if there's another point given, another constraint, you want to set it up in this form. Same form, but adding an a in front, a transformational multiplier, and then plugging in the point for your x and y, plugging in all the roots, and solving for that a. Okay, that's not always necessary, but it could be. Okay, Jimmy, yes, I see the follow-up. Jimmy's saying, what if they aren't roots? They will be roots. How's that? For a quick answer on the multiple or the marked period 2 exam, they will be roots. If they're not roots, you would need a system of equations that we set up back when we did the artillery problem, but not for tomorrow, not for the marked period exam. It will be roots, or at least you'll be given a bunch of the roots. Maybe there's a conjugate theorem involved where you need to get the other root. Will there be problems where we have to do limits? Good question. Yes. There are 2 multiple choice questions involving limits. Excellent questions tonight. I must commend the questions. See if anybody else joins us with a hi, but okay. Oh, Beata is here. Did not see that originally. And Sam. And Jess, I'm not sure you ever got a shout out. And Kang is in italics. Very interesting. Okay, I think that all contributes to a useful webinar. Thank you for joining us, everyone. Thank you very much. Will there be a question similar to number 3 on the Chapter 5 test? pull that up. Contrary to popular belief, I don't have all the tests memorized. Chapter 5, number 3. The Google Drive, Chapter 5. Appears I did not upload it there. Give me 1 second. I have it on my other computer, which is next to me. Chapter 5 test. There is no number 5 on the chapter. Oh, number 3, you said. Helga. Oh, the Helga problem. If you said the Helga problem, I would have got that right away. Oh, thank you, Brenda. You're clarifying now. Thank you. No. It's a great question. I love that question. I hope you know how to do it, but no. Not going to be a Helga problem. That problem alone can take you a good 10 minutes or at least 8 minutes, let's say, and you're just not going to have that kind of a time on a cumulative exam for one question. So no. Helga building a shed, that's great. Great problem, but not on there. What is the rational root theorem? Okay, again, you might want to see that Chapter 5 webinar. I believe it's discussed there, but in brief, I can describe it for you. It says, any polynomial you know what, it's going to be easiest for me to draw on the sketchpad for this. So I'm just going to say, see video presentation. Let me draw on the sketchpad, and we'll go from there. Remember, if you can stay on to the end, we're going to have a special bonus for those multiple choice questions. It's a little extra incentive, but let's look at the, that's not it. Sketchpad go. Oh, here it is. Okay. I'm going to delete everything. Put that to the side. Delete. So the question was the rational root theorem. Rational root theorem, it says if you have a function and it has a rational root, the rational root will automatically be of the form of P over Q. If there's a rational root, it'll be P over Q, where P over Q represents factors of the constant and factors of the leading coefficient. P is the factors of the constant. Q is the factors of the leading coefficient. Okay, so in that case, you get a set with a bunch of possibilities. You remember we tested these possibilities? So the first possibility is just look at the factors of the constant. You divide by factors of the leading coefficient. So this would be, you know, plus or minus 1, plus or minus 2. I'm just thinking all factors of 8. Plus or minus 4, and plus or minus 8. Then we can divide each of those by factors of 2, which are 1 and 2. Dividing them by 1 just gives us those. Dividing them by 2 yields a couple more. We have plus or minus a half. And I think that's it in this case, because 8 over 2 and 4 over 2 are just going to give us stuff already on this list. So in this case, there would be 1, 2, 3, 4, 5 times 2. There's actually 10 possibilities for roots. One of the multiple choice questions will ask you maybe how many possibilities, and that's how you figure that out for the rational root theorem. Okay, I hope that rings a bell. Can you please give us the answers to the back of the review sheet and share the PowerPoint you had at the beginning? No problemo. Yes. Stay tuned for an email around 9:15. Okay, so after this is over, I'll gather everything together, the replay, the answers, etc. I might be posting some of those on the website, though, so I'll let you know where it is. But absolutely, you are entitled to that. Okay. And the first question answered, how would you find a root? Synthetic division? Well, not really. There's a couple ways to find roots. Synthetic division is what you do when you already have a root. To find the roots, you'll either be given a root, or you have to, how can I write this? Either, I want to number this. A, you're given the root. B, you're given a complex or irrational root, and therefore you know the conjugate is already a root. Or C, you have to use the rational, not copy, right? Come on. Use the rational root test to figure out which ones are roots. That's where the calculator is helpful. But synthetic is what to use after you know a root. After you know the root, you use synthetic division. It's used to press the equation. Okay. There. If you want to go back, that'd be helpful to me. I'm just curious. Go back, put your name next to a question if you answered it, or sorry, if you asked it, just so I know who asked specific questions. It's sometimes helpful to reference that in class so I know who's asking what. Just go back next to the question in color and put your name if you can. Somewhat unrelated. Will there be extra help after school since school was canceled today? Yes, but it's got to be limited. Yes, until 3:30 p.m. That's really all I can do because I have class all night on Tuesdays and Thursdays. I will be here tomorrow morning as well. I'll be in the morning at 7:40 as well. Okay, look at all these questions. Loving it. Some people are just like, just stop with the questions so we can get to this bonus he keeps talking about. Remember, you're like, oh, I don't know what this bonus is. Trust me, it's going to be a useful bonus. What is the vertical and horizontal asymptotes? Again, I know what they are, but how do you find them? Okay, so what are they? And then in the next sentence, this person declares that they know what they are, but how do you find them? Okay, good question. You can go back, put your names next to these questions. I'm always curious. Who's asking these questions? How do I know, your parents or your brother or sister haven't snuck on and asked their own questions, which is so good. It's perfectly fine. If they want to hang out at this webinar, the more the merrier. How do you find them? Again, Jimmy, you don't need to apologize. Horizontal asymptotes, see the Chapter 8 webinar. I really went over these, horizontal and vertical. I believe I kind of remember doing it, so see that, but I'll just briefly, horizontal asymptotes, you have to check limits as x goes to infinity. And remember, you only consider the leading terms of the numerator and denominator. For vertical, and then you simplify and see what you get. For vertical asymptotes, you have to check what makes the denominator 0. Okay. That's the asymptotes. Basics of that. Okay. Number 3 on the back of the review. Let's look at that. Let's look at that. Absolutely. I would like to do that. I just have to find it. Good question, Robbie. I'm going to pull up that question now, and we can look at it together. Number 3 on the back of the review. Okay. Okay. Yeah. Okay. I'll set it up for you. How's that? Number 3 on the back of the review. That's the study guide that I gave. Remember, this is only Chapter 4 questions. This is not everything you need to know. I'm sorry, Chapter 5. But it's a good sampling of chapter 5 questions that are similar to ones you might see. I'm going to set it up, Robbie, and then we'll see how far we get in time constraints with this problem. But again, this gives you, it says write a cubic function, and it gives you a bunch of the roots. If you can look at those ordered pairs, you notice 3 of them are x-intercepts. So we know that the roots are, I'm just going to label them R1, R2, R3. We know one root is -2. We know another root is -1. And by the way, folks, this is number 3 on the back of the review. If you're looking, following along. And we know the third root is 2. So a cubic function only has 3 roots there. So a cubic function only has 3 roots. So if they give you 3 roots, then you're in good shape. Sorry, oh no, made a little boo-boo there. This should be a 2. Sorry about that. Almost another board point. That's a 2. So if you're given the 3 roots, you know you can set up your function like this. X minus R1, which will be give me x plus 2. Then it'll be x minus R2, which will be x plus 1. And then it'll be x minus R3, which will be x minus 2. And then you multiply it out. The difference about number 3 is they also give you another point. So they don't just say write an equation with these roots. They say it's got to go through all those points. So we also have to take into account 0, -8. It has to pass through that point as our y and x. So all that means is that we need to introduce another constant here, a, that we can solve for. So I'm going to change the f of x to y, and a, x plus 2, x plus 1, or x minus 2. So they don't just want any cubic function with these roots. They want the cubic function that passes through this point. And that gives a little bit more specified information, which means we're going to have to consider the possibility that this constant a in front could be some different number. Okay, no, the roots can't change. They gave you the roots, but there could be a number that's multiplied by this equation to change it slightly or transform its shape a little bit. So in order to get the exact one that they want, we're going to have to first change the color of my pen. Okay, and then I'm going to plug in this for x and this for y and simply solve for that a. So I do a -8 here, equals a times, and then x is 0. So this is simply 2, 1, -1, plugging in 0 for x. I'm sorry, -2. And -8 equals -4a. Therefore, a equals 2. And you can rewrite this function with a as 2, and then you'll have your result. Of course, on the exam, I'll probably ask for it in standard form, and you will have to multiply these factors out. And you can use your FOIL method, your multiplication methods. Okay, hope that helps. See video presentation. All right, thank you, Robbie and Jimmy, for putting your names next to your questions. Other people have still not done that. If you go back, oh, Gwen, thank you. You can go back and do that. I'd appreciate it. I'd like to know who's asking questions, who's participating fully. Okay, this is like classic, someone I need to block. I know for a fact that Jess Murphy would never type this on a review webinar. So I'm going to go back and look at the history of who wrote this sentence. And next time, maybe I'll have to block you from this Google Doc. But I'm glad you're confident on how to find the rational roots. Who is the troll? Yeah, and she would never write Jess Murph. Come on. It's clearly an impersonation that has occurred. All right, continuing. Okay, yeah, Jimmy, you would. You know what? Don't, or I'll just block you and you won't be able to ask any more questions. And who's the troll? Hint. I'm distracted. Sorry. Circus here that's going on. It's become this webinar. It's not. Don't say Beata. It's not Beata. It's never Beata. You guys just try to pin it on her. Which, believe it or not, I don't know what happened with Bayada with the mock trial because the snow destroyed it. But hopefully your trial is rescheduled. Oh, thank you. Okay, it was Jimmy. Jimmy, you're getting blocked. Will there, okay, Victoria, let's get back to some real math here. Thank you. Will there be any matching questions where we have to match the graph to the equation? Yes. On the multiple choice, there will be some. It'll give you a graph, and either using end behavior, intercepts, asymptotes, you'll have to pick the equation from 4 or 5 options on the multiple choice. Awesome question from Ryan, very specific and to the point. Which of the parent functions have asymptotes? There's really only one that we've seen. Only one that has an asymptote, that's a parent function. I'm going to give a ticket to the first student who can answer this one. Your student answer next to where I wrote student answer. What is the only parent function as a student that has an asymptote? It appears we have a battle going on. That is correct. Okay, that is correct. I have Robbie and Trevor and Sam. Trevor says he got that in. I have Robbie over here. Victoria, no. Sorry. It looks like Robbie might have been the first, but you can't self-proclaim that. Anyway, Ryan, they are correct. We'll sort that ticket out tomorrow. But it was y equals 1 over x. That's the only one that has an intercept. Okay, I don't need 50 people saying who it was. I will look at the video. We'll use some instant replay here, and we'll sort that out tomorrow. Y equals 1 over x. Oh boy. Okay, can I go over limits? Can you be more specific? I can say that I'll give just a couple basic remarks. For limits at infinity, plus or minus infinity, you only consider the leading terms of the numerator and denominator and simplify that expression to reveal the limit. For limits at a number, you have to inspect the expression carefully, looking for teeny tiny numbers and being very careful to know the sign of particular components. The other thing you have to do is factor everything. Factor everything before you look at the limits so you can tell what's going on, especially that denominator. That's just some general remarks, Sam. I will gladly go over 1 or 2 in class if you have a specific limit in mind. There are 2 multiple choice questions with limits, and they might also be helpful for asymptotes and other problems. So you should know the gist of limits. How are we doing on time here? Okay, 8:40. We got about 5 minutes left on the regular webinar. And then if we have to do a little bit of overtime, we can. I want to make sure I get that bonus out at 8:45 though. Here, when you did the rational root thing in the PowerPoint, would plus or minus 1/4? No. Those would not be roots. Since you divide by the factors of the leading coefficient only. Okay, it's not taking factors of both and just dividing them in any possible combination. You only do the constant over the leading coefficient. So the way I set it up is the only way to do that's the rational root theorem. If you disregard that, then you just take all possible combinations, you'll get too many. So just be careful. You want to do it exactly as I did. Okay, we're getting their last minute questions in. And very close to that bonus. Will there be a question about finding all the zeros and non-zeros of the function? Thank you, Brenda, for the question. It doesn't say find all the zeros. Zeros will be relevant to several questions. That's what I can say. It will be relevant to several questions. You might have to set up one like I just showed Robbie on the sketchpad. You might have to determine how many zeros there are, but the question, it may not say just find them all. Well, here's in the context where it would. There will be questions where it says solve an equation. And in a sense, solving an equation is kind of like finding all the zeros of a function. So you will need to know how to solve different types of equations. And I said that in the PowerPoint. Rational, polynomial, and radical equations, which can involve zeros. I'm not sure what you mean by non-zeros of a function. Can you clarify that, Brenda? I want to answer, but just not sure what you mean. Okay, so clarify that. I'm going to go on to the next question. Run out of time. Rapid fire here. In class tomorrow, can you go over how to write an equation when given roots and one other point that isn't a root? Yes, I can. But Juliana, it would be very helpful if you can tell me what was unclear in the explanation I gave Robbie. I'm not saying it was a great explanation. I just want to know what didn't you understand, because I just showed steps on the sketchpad about 5 minutes ago. What was unclear in the answer to question number 13? This was Robbie's question above. If you can take a look at that, and if you could tell me what was unclear, or if you were watching and you saw it was unclear, that'd be helpful, because then I could say, oh, that part didn't make sense, and I'll try to make more sense of it for you. But please let me know if you have that. Oh, non-real zeros, Brenda. Thank you for the correction. Good point. Yes, you might. Yes, I'm not saying there definitely will be one, but you should know how to find non-real as well as real zeros, also irrational zeros. And basically that comes down to you want to depress until you get a quadratic. If you have an equation that has 4 or 5 roots, you want to depress it until you get a quadratic. You depress it with the rational roots, the real zeros that are either a whole number or a fraction. You depress it until you get a quadratic, and then you use quadratic formula. If it can't be factored, you can use quadratic formula, and that will reveal the imaginary roots. Okay, a couple of questions here, and then I got to get to that bonus because that'll answer question number 21. We are winding down. How will we know if there are asymptotes or not? Good question. Basically, a rational function is what you're looking at. If it's not a rational function, there's no way it has asymptotes. We haven't seen anything with asymptotes that's not. I'm sorry, we did see exponentials, but they're not on the marking period exam. But so if it's a rational function, there may be asymptotes. So there's 2 ways to check what they are. Check if the denominator could equal 0. What values make it equal 0? And you also want to check the limits at infinity. Okay, if the limit at infinity exists, meaning it equals a definite number, then that will tell you that there is a horizontal asymptote. So that's really how you want to check if there are asymptotes, and only rational functions will be relevant. And we're going to get to our bonus that I've been talking about. In class tomorrow, I will be specifically reviewing first. Good question, Brenda. Thank you. We'll check answers to the chapter 5 questions. I'll take questions on those. And then we're going to work on the bonus worksheet or the handout, which you'll get a head start on for tonight. And then I'll allow some individual study time and time for more questions. Is there anything that we would have done in class today that would have been important for the test? Nah. You would have had time to ask these types of questions in class. We would have gone over those chapter 5 questions in class. Not a ton. We were going to finish the exponential stuff. We would have done exponentials and check that homework, and then we would have gone on to the chapter 5 questions, and I would have allowed you to ask more review questions. So what's this bonus I've been talking about? Thank you for those of you who have stayed on this far. The bonus is a special multiple choice review. So I'm going to go into my Google Doc and let's see if I can find it. That is the sound of the bonus. There it is. So you will be, if you are watching this webinar, you will be receiving this tonight. And what it is, you can get started on it if you want. We are going to look at it a little bit in class, but those of you watching, this is your special bonus. You're going to get it tonight. It's a review for the multiple choice marking period exam, multiple choice questions. And what I have is I have strategically written 14 concept questions asking you to recall certain concepts or methods. 14 questions, huh? Well, where did I get the number 14? Well, it just so happens that 14 is the same number of multiple choice questions on the test. So if you have to think about how I came up with these different statements, you might just say that I went through the exam and wrote out a question based on each multiple choice question. And that if you can answer these questions, then you should be able to answer the multiple choice question that corresponds to said question. So they're concept-based. They're not just like solve an example, but for example, how can we identify the leading coefficient and degree from a graph? Talk about it. Write some bullet points to yourself. How can you do it? If you know how to do that, you'll get that question right. How can we factor a polynomial of degree 3? What are the possible methods? If you know how to do it, you'll get that question right. Number 7, what are the laws of exponents that we need in simplifying? A lot of you are a little rusty on those. What are all those laws? If you know how to apply each of those, you'll get question 7 right. Now also, since this sheet doesn't have examples, it has the concepts behind the multiple choice questions. You might also want to look up some examples on your own. So for example, if you need something on the rational root theorem, what does it tell us about a function? It tells us the possible rational roots, and we find them with that P over Q set that we set up. But you might want to do an example of that. So at that point, you would go back, look at a TPS, look at a chapter question, look at something from the textbook, and find some examples for yourself. But if you can answer this 2-page sheet, and you can quiz each other, how can we calculate limits as x goes to plus or minus infinity? If you can answer all of those, that multiple choice is going to be smooth sailing. Okay, so that's your bonus. You're going to get that in an email at 9:15 if you want to get started on it tonight. If not, everyone will get one in class, but only those at this webinar are going to see it early because they've been watching out for it. So thank you so much for watching. And God bless this worksheet. Barteen is my new favorite number. Thank you for the comments, and I will be sending that out shortly. All righty. Have a great night, everybody. And I'm going to block everyone from this Google Doc so that you don't get lost in all the comments that are extraneous. Oh, I just said that word, extraneous. Don't forget about extraneous solutions. Good night.